this lesson is about the zeros of polynomials, and it really kind of puts together some other things that we have. So back in 4.3, we pointed out that if you can plug in a number and equal a 0, then that number is a 0, and x minus that number is a factor. So if you know the values of the zeros, then you can write the factors. And if you can write the factors, you can multiply them together to get the polynomial. So one of the things you deal with is instructions that say find a polynomial with the lowest degree having the given numbers as zeros. Now don't worry about this idea that it says the lowest degree, because you're not going to accidentally find one with a higher degree unless you just start throwing in some extra terms that you don't need to. We don't tend to throw in extra work that we don't need. So what we do is each one of these is a 0, and we want to do x minus the value that's given. So we're going to start with x minus 2, and then x minus negative 2, of course, will become a plus, so we'll constantly be changing what we see in the sign over here into what I put as the factor. So with a 3, we put x minus 3. Now we're going to multiply this together, and we'll have our polynomial. You generally want to multiply either the easy stuff that fits a pattern or the ugly stuff first. So here what I'm going to do is multiply those together. Anytime you have the conjugate, then we get the first thing squared minus the second thing squared. All right, so now I can just FOIL this together. So I have first, outside, inside, and last. And this should be my answer. However, sometimes you maybe just aren't quite confident you multiplied everything together correctly. So I want to give you a tip on a way that you can kind of check this with your graphing calculator. So on your graphing calculator, if you'll hit apps, you may have a different listing of the number of apps. You might not have all of these. You might need to scroll down further, but you're looking for something that looks like this last one. And I tend to call that polysmult. I know that's not actually a word, but you can see where I might get that pronunciation. It doesn't have to have a 2 after it, although if it doesn't, it'll be slightly different than what you're seeing here. If it doesn't have the 2, then when you select that one, you'll get a screen that says press any key to continue. Whereas if I hit this, I go immediately into this menu. Now, either way, we'll have a menu where we can choose this very first one, Polynomial Root Finder. And what we're going to do is type in the polynomial I just found and let the calculator tell me if those were really the roots. So I'm going to choose option 1. And the order has to do with the power of the polynomial. So I want to go back and look at my answer for just a minute. So this is an x cubed, which means it is a 3rd degree polynomial. Now, since none of my answers were supposed to be imaginary, I could put this in real, but it doesn't hurt to leave it over here in a plus bi. It doesn't make much difference. Really, everything is set. I don't want to change anything else. I just want to do next, and that should be displayed on your calculator right above your graph button. So I'm going to hit graph. And now I'm going to put in the numbers so it will match up what I got for polynomial. If you have the older version of this, if it didn't have the 2 at the end, you actually just have vertical listing that says like a sub 3, a sub 2, a sub 1, and a sub 0. That's still just asking for your numbers. So you would put in 1, -3, -4, and 12. Now when I do it in here, I have to hit an enter in between each one. So it's 1, -3, -4, and then positive 12. And now once I have them all, and if you've got them all vertical, that's fine. We want to solve, which is up above graph. And I get this result that my zeros for the function I entered are 3, 2, and -2. And over here I had 3, 2, and -2. So I'm confident that that was the correct answer. Definitely got this one right. So the next couple of screens are just like that, but we've got a little bit more complication on our zeros. Exact same instructions. But here's the deal. If you have an irrational number, they came in pairs. because the only way this root actually happens is if it came from like a quadratic equation, which has that plus or minus the square root section in it. And so if you have the positive on a square root, you've got the negative on a square root if it was a solution. So those come in pairs. So to multiply this one, my very first one is x minus 0. But x minus 0 is just x. And then I have x minus 1 plus the square root of 2. Then I also have x minus my other root, which was 1 minus the square root of 2. If you have the one, you have them both. Those irrationals come in pairs. So now this is what I meant. You might want to multiply the ones that are easy or the ones that are ugly. These are definitely the ugliest. So I'm going to multiply them together first, and we'll just carry that x along without doing anything with it yet. So the x I've just copied over. So here for this one, I'm going to just be very, very careful when I do FOIL. I have first, outside, okay, so that's going to give me a negative, and then an x times 1 minus root 2. And then inside, I have a negative and an x times 1 plus the square root of 2. And then for my last ones, a negative times a negative is a positive. And I have this 1 plus the square root of 2 times 1 minus the square root of 2. So this won't happen to you too often, but we can't say it doesn't happen. So right now, I'm just going to work very carefully on what I call algebra cleanup. We're going to distribute and combine and see what we can do. So this x, I am simply copying along for the ride. So now I have x squared. Now I'm going to take this negative x and distribute it. So I have negative 1x plus, negative times a negative was a plus, the square root of 2x. Now I'm going to do that again over here. So I have a negative 1x minus the square root of 2x. I'm at this section, I need to multiply this stuff together. But these are identical except for that sign in between, which means I'll get the first thing squared minus the second thing squared. So the square root of 2 squared is just 2. A plus in front of that. All right, another line of cleanup. But yay, now it's actually going to get better because this negative x and this negative x are like terms. So I'm going to combine those. And this 1 and this 2 are like terms. On the other hand, this positive root 2x and the negative root 2x cancel out. So I don't have to deal with those any longer. So now I have x squared. Combining these, I have negative 2x. And then combining my like terms over here, I have minus 1. Man, that got a lot better. Now I can just distribute my x and have x cubed minus 2x squared minus x. Now this should be my answer, but particularly on a problem like this that has been so ugly, I'd like to check it. However, I need to know something about this first because my calculator is not going to be able to display a square root of 2. It just doesn't do it. It's going to put that in decimal form. So I'm just going to say I know that the square root of 2 is approximately 1.4. You could easily punch that into your calculator and get it. So really, to do a check, my calculator needs to give me a 0, a 1 plus the square root of 2, so that'll be approximately 2.4. It's going to keep going. And then 1 minus 1.4 will be like a negative 0.4, and that's going to keep going. So if I've done all my multiplication right, those are the answers I would be looking for on my calculator, and we'll bring it back up now. So again, I got here, this is underneath that app, and then go down to number 9, at least on mine it's number 9, it looks like polysmult. But I want to change this polynomial now. So if it's still a third degree, which this one is, I can just change the coefficients. Coef is up above your third button over, so it should be right over your zoom. It is still 1x cubed. And it's still a minus. It's minus 2x squared minus, that's just a 1x. And I don't have any plain constants, so I've got to change that to 0. So now when I hit solve, fingers crossed, the negative 0.4, the 2.4, and the 0, yes, it matches. So it's going to give it to you in decimal form, but you can still use it to help. So this one's correct also. So this process stays the same, but I feel obligated to show you one more here because of the i's. The i's also come in pairs. Irrational come in pairs. Complex come in pairs. Imaginaries come in pairs. All of the weird ones come in pairs. So if you have an I, you also have a negative I. Plus or minus here. And that means I've got a plus or minus here. So when I start lining this one up, I have x minus I, x plus I, x minus 2I, x plus 2I, x minus 1, and x plus 1. So what we can see here is that these, actually the conjugates that are imaginary are not nearly so bad to multiply. But these are the groupings that I want to start with. It's not like you get it wrong if you did it in a different order, but it would sure be more difficult. Anytime they're exactly the same, except for that middle sign, it's the first thing squared minus the second thing squared. So I could put I squared here, because that'd be correct, but don't forget I squared is negative 1, which will just change that sign. This next one then will be x squared minus 4i squared, but the I squared will just change that sign. Now these are real numbers, so we've got x minus, and then 1 squared is 1. But I've left off my squared, x squared minus 1. So now I have those 3 to multiply. You can do it in any order you want to. But if you look at this one, and then you look at this one, again, I can use that pattern because they're exactly the same except for the middle sign. So those give me the first thing squared minus the second thing squared. And then I still have x squared plus 4 here. So now I'm going to FOIL this together. First, outside, inside, last. So I believe this is my answer. It's a 6th degree, but I want to check it. Going back to my calculator, on this one, because I've got more than just the coefficients to change, I have to back up a previous one, so I need to go to the mode, which is above window. And that's where I can change this from a 3rd degree order to a 6th degree to match my x to the 6. Now the moment you mark that over, you no longer have an option to choose here. Your calculator just kind of goes into overload. Everything else is fine, so next is above graph. And notice now my only option is to put it down vertically. And again, if your calculator didn't have the polysmult 2, this is already what you were dealing with. But I'm still just going to put in my coefficients. So I have 1x to the 6th, 0x to the 5th, 4x to the 4th, 0x cubed, negative 1x squared, 0x to the 1st, and then a negative 4 is my constant. So after you enter all of those, we want to solve, which is above graph. And here are my solutions. Plus or minus 2i, plus or minus 1, and plus or minus I. So I got all of those roots So I did this one right. So your calculator can certainly help you check, and anytime we have a lot of multiplication, that's a great thing to do because it's just too many places we can make an error. Let's look at another concept then. We can take one root if we have, or even if we know two, any zeros you know, but you don't have to know a lot of them yet. You can use synthetic division and reduce your polynomial, and then you could possibly solve what's left. When you look at the complex number, every polynomial of degree n has n zeros. Now, they're not necessarily unique, and we're not saying they're all real. When we say it's not unique, it's like you could have the same factor repeat itself. So if we have complex zeros, the complex zeros can be real or imaginary, or they could have a real part and an imaginary part. Real numbers can be irrational or rational. But notice I've got this imaginary, anything with the imaginary and anything irrational is going to come in the pairs. So if you have plus, you're going to have a minus in between. How do we get the first known zero if it's not just told? This is the big trick of the day. We have a really scary looking theorem here. And this is the technicality of it. So how can I rephrase all of this stuff so that you can actually just apply it? Well, that's the part that's written under in blue down here. We're going to take the factors of P and the factors Q, and we're going to form fractions. Now, where does P come from? P comes from the constant, and Q comes from the leading coefficient. So what we're going to do is actually look at our last number, and we're going to say, well, what all could be a factor of that number? And when we look at the last number, we look at the last one first. First should be last, last should be first. We're going to make options for P. So P comes from factors of that very last number. Then we look at the leading coefficient, okay? And that's where we make a list of numbers that could possibly be Q. We look at the factors there. Then we're going to make a list of fractions, and they will be both positive and negatives of P over Q. After we get that list is called the possible rational roots. That's your possible rational roots. Then we have to see if any of them actually work. So what we do is we're going to plug them in and find out if any of them actually equals 0. And if it does equal 0, then we will know that we have an actual root, not just a possible. Then we can use that. Oh, so these are multi-step problems, but let's look at one then completely. This is exactly what the homework would look like on these. They're going to give you a polynomial and ask you to find the rationals and then the other zeros, and then factor into linear factors. So they've even added more than I said. Even though they only ask you to find the rational zeros, you can't do that unless you find the possible rational zeros. And you can't find the possibles unless you deal with P and then deal with Q. So we look here at the end of this. It doesn't really matter if you consider the minus or not, because when we make our P over Q list, they have to be both positive and negative. So what are the things that could be factors of 4? 1 and 4, or 2 times 2. So those are the only things that actually go into 4. Then we look at our leading coefficient to deal with possible numbers for Q. So Q is either 1 or 3. Then we're going to make a possible root list. Now this is a possible rational root list, and it comes from P over Q. And the main thing I can tell you is be organized. You can have a very long listing of possibles. And so the way I do it is I deal with all of the P's over each of the Q's. Like I will take all of these numbers over the first Q, all of these numbers over the second Q, and then you have to do them all in negatives also. All of the P's 1, 2, and 4 over 1. So that's my first set. Then I have all of those numbers over 3. So I have 1/3, 2/3, and 4/3. However, you also have the negatives. So I could have -1, -2, -4, -1/3, -2/3, and -4/3. Now, this can be kind of an annoying thing on the homework, and I apologize for that, but you will have to list all of these numbers. Don't forget a comma, don't forget your negatives, and make sure you're organized about it. All of the P's over each Q, and you have to do both positives and negatives. That wasn't even in the instructions, but we still had to do it. Now we need to find the actual rational zeros. The way we do that is we need to plug these numbers in to our function and find out where it equals 0. So we're going to find, when it says find the rationals, what we're actually looking for is we want to take that P over Q, plug it into our function f, and find out where it equals 0. And the fastest way you can do that is certainly to use your table of values on the calculator. I want to go to y equals, and I want to type in this polynomial I was given. So I have 3x to the 4th minus 11x cubed plus 10x minus 4. And then I'm going to go to my table of values. Now, I think we've talked about this enough times. If you already have a list here and you can type over it, just keep typing over them. It doesn't really clear them out. If it won't let you type, then you need to go to your table set right here and make sure that your independent is set on ask. That's the key right here. Independent is set on ask. But now, what this is showing me is what it equals when I plug numbers in. So I'm going to start typing these P numbers in and looking for anything that makes it equal 0. Even though this is a fraction up there, you're fine to just do 1 divided by 3. Down here, it'll change it to a decimal. Look, I just hit 1. 2 divided by 3 right here equals 0. So I know that I have 1 right here. Now I'm just going to keep going. So now I've got 4 divided by 3. Okay, so I have finished all of my positive ones, and now I'm going to move into the negatives. I just as well go back up and start typing over them. So now I have -1. Oh, I put a minus, guys. Sorry about that. So -1, and then -2, -4. Now notice I did get another 0 right here at -1. I'm going to go back and mark that in a minute. Then I had -1/3, -2/3, and then -4/3. So I did get a second 0 though at -1. Now those are the only 2 I got. So when it says find the rational zeros on your homework, that's when you will have had to have checked to see which ones make it equal 0, and your rationals, and I think they say zeros instead of roots, it's all the same. I had 2/3 and -1. Then it says find the other zeros. Well, see, that's not a lot of instruction, but what you're going to do is take this original one and use synthetic division. So if I take 2/3 and then I put these coefficients, so I have 3x to the 4th, -11x to the 3rd, 0x squared, 10x to the 1st, and -4. So I didn't skip any powers. That's 4, 3, 2, 1, nothing. So doing my synthetic division, remember we add going down and then we multiply. And by the way, when you're multiplying by a fraction, of course you can use your calculator, but you can multiply by the top number and then divide by the bottom. Do the same thing. It's often easier for people. So here I can say 3 times 2 is 6, divided by 3 is 2. Or you could divide first also. Like 3 divided by 3 is 1 times 2 is 2. You just deal with it like it's two different numbers. So now when I add those, I get negative 9. So if I divide first, negative 9 divided by 3 is negative 3 times 2 is negative 6. Add. And then do my two operations. So I've got to divide that and then multiply it, or multiply and then divide, and I get negative 4. Add, and I have 6. Multiply by 2/3, so you do the two parts, I get positive 4, 0. So I took out one of my roots. This is called reducing the polynomial, but I can reduce it by a second one also, guys, because if you look, I have a 0 over here at negative 1. So that's one of the great things about synthetic is you can just stack it. So now I have 3, negative 3, negative 12, 12, 6, negative 6, 0. Okay, so my reduced polynomial then, if it started as a 4th degree and I took out 2 of those roots, this is now an x squared. So 3x squared minus 12x plus 6. That's what's left. And notice it says I've got to find the other zeros. So I'm going to take this 3x squared minus 12x plus 6 and solve it. So I set it equal to 0. Now, first of all, please don't try to factor it. I mean, I can't stop you, but that's going to be a waste of time. You're not going to, none of these are going to factor after you take out all the rational zeros, because factoring only works for rational zeros. But what I can do here is divide everything by 3, so I'll have smaller numbers. So I have x squared minus 4x plus 2 equals 0. And then I can use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, you want to simplify what's in here first. So that's going to be 16, and that's 8. 16 minus 8 is 8. So we end up with 4 plus or minus the square root of 8. The square root of 8 simplifies it. It's 2 root 2. And it's all over 2. Now, these numbers that, not the one that's under the radical, but these other 3, I can put that 2 into both of them to reduce it. So that gives me, for my other root, 2 plus or minus root 2. And that is the other zeros. So see, I found 2 of them in the first place, and then I found 2 more of them after I finished all that. This last part says factor it into linear factors. Well, now that you know all the roots, you can write all the factors, because there's sure a lot going on here. But if I want to write it as linear factors, I have x minus, x minus, x minus. So I don't quite know where I'm going to put that, but if I say, well, now on this one, what we do is kind of use bottoms up. This one becomes 3x plus 2. Not plus 2, minus 2. It is kind of like bottoms up, but it does change the sign here. The solution to this one, if this equaled 0, would be a positive 2 over 3. So this is the root that goes with that solution. So instead of just writing x minus 2/3, the bottom number swings up to the front. So it's similar to that. And then we have x plus 1. And then x minus our ugly root, 2 plus root 2. And then I wish I could fit it right there, but then we also have x minus the other ugly root, 2 minus root 2. And all of this is what it means when it says write it in linear factors. It's complex. So you're looking at this thinking, wow, we've done so much. Well, you really have at this point. You have just taken a polynomial and found all of the zeros and whether or not they're rational or irrational and written the entire thing into linear factors from an upper level that didn't just factor. That's pretty grand. So let's do one more of these totally, and then the rest of it is your practice because there's nothing else going on the concept. As I go through this, maybe I can write a little bit smaller on some of this, but P comes from the last one. I do have plus or minuses I'm considering, but it's 1 and 15, and then 3 and 5. So 1, 3, 5, and 15. At least, though, when I look at my numbers for Q, I just have 1 and 2. And don't forget, this over here was P. So when I look at my possibles, I'm just trying to write a little bit less now. Although when you're doing this online, you do have to type them all out. I am just going to put a plus and a minus to save myself some room right here. And so it'll be the positive and negatives of all these numbers I put. And don't forget the possibles is your listing of your P's over Q's, every way that you can combine it. So if I take 1, 3, 5, and 15 and put them over 1, I get those. And then I want to take 1, 3, 5, and 15 and put them over 2. Now let me say, if you did have something that reduced, so like suppose that this number right here had been a 3, 15 over 3 is 5. And if you've already got it listed, you've already got it listed. You don't have to list it again. But now my possible list of rationals is twice as long as it looks like here because it's all of these as well as all of the negatives of them. So then I'm going to find the actual rational zeros. Okay, this is where I'm going to go to my calculator and I'm going to type in my f of x, then use my table of values to start plugging in things and see what makes it equal 0. Now guys, I don't always remember to do this, but you know, when you're typing in a lot, let's just check, make sure I typed it in right. 2x to the 5th minus x to the 4th minus 4x cubed plus 2x squared minus 30x plus 15. Okay, now I'm ready to go to my table of values. So that's second graph. And I'm just going to be typing over these x numbers to put in those p over q numbers. So I have 1, 3, 5, 15. None of those work. Now be real careful when you're doing this. Watch out for anything that has, I know that's awfully small for you guys. Let me make it big for a minute. Anything that has an E in it, because it's telling you how far to move the decimal. So this is positive, so we would be moving it way over to the right. And if you needed to know what that number actually was, you know, you can see it here where they've actually moved that decimal over if you highlight it. Okay, so just watch closely for E's. So I did the 1, 3, 5, and 15. So now I need to do the 1/2, 3, or 1 over 2, 3 over 2, and so on. 1 over 2, 3 over 2, 5 over 2. Oh, that was 5 over 3, wasn't it? 5 over 2. And 15 over 2. All right, so I did get a 0 at 1/2. So let me go ahead and write that one down before I try all my negatives. And that's right here. When I put in 1/2, I got a 0. But I haven't tried any of the negatives yet. I just as well go ahead and try as many of those as I can. -1, 3, negative 5, negative 15, negative 1/2, negative 3/2, and negative 5/2, and negative 15/2. So as you look here, I did not get another 0. So I only got 1 out of all of that, but at least I have 1. What do you do next? Once you have the actual rationals, you're ready to do your synthetic division. So I'm going to put my 1/2 over here, put all of those coefficients listed out, so you don't want to skip any powers. 2x to the 5th, negative 1x to the 4th, negative 4x cubed, positive 2x squared, minus 30x to the 1st, and a positive 15. Ooh, we wish I could draw a straight line on this little board. Okay. Bring down the 2 times 1/2. Add times 1/2. Add times 1/2. Add times 1/2. Add times 1/2. Add. So if this was an x to the 5th, and I've taken one root out, what I have down here now represents an x to the 4th. So I have 2x to the 4th, 0x cubed, negative 4x squared, 0x minus 30. So those terms are going to go away, and I've actually got 2x to the 4th minus 4x squared minus 30. And I need to set that equal to 0 so I can solve it. However, since they're all even, I could divide them all by 2 first, and then I've got smaller numbers to work with. So I've got x to the 4th minus 2x squared minus 15 equals 0. It's not going to factor. It's never going to factor after you've had to do the p over q's and taken all those out. But this is quadratic in form because it's got the 3 terms. So I can use the quadratic formula. Up here at the top, I'm going to say x squared equals, so not x, but x squared, and then we'll use our quadratic. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to simplify that some more. So x squared equals, inside here, negative 2 squared is 4. A negative times a negative is a positive. And 4 times 15 is 60. So we end up with 2 plus or minus, now the square root of 64 is 8 over 2. So what are the 2 answers we get here? We get 2 plus 8 is 10, and 10 divided by 2 is 5. 2 minus 8 is negative 6, and negative 6 divided by 2 is negative 3. Now don't get too confused, we're not done yet, because that's what x squared equals. So if x squared equals 5, then x is equal to plus or minus the square root of 5. If x squared, on the other hand, equals negative 3, then x is equal to plus or minus the square root of negative 3, which we know I will put as an I. So I actually have this rational root here at 1/2. Then I have 2 irrationals here, and then I have 2 more that have an imaginary with them. So that gives me a total of 5, which accounts for all 5 of them from that very first exponent. To write my answer in linear factors, x minus the root, x minus the root, x minus the root, I would say x minus 1/2, but I know that that 2 needs to swing up to the front. Bottom goes up to the front. And then I have x minus root 5, x plus root 5, x minus I root 3, and x plus I root 3. So that's 1, 2, 3, 4, 5 factors we've accounted for. It is a lengthy process. Try not to cram your work up. I kind of had to on the slide, but usually you want to just write real clearly so that you can double check your work and see what's going on. If you feel like your head's about to explode, I get it. Send me any questions you have. Thanks.